Hi, everyone. My name is Kayleigh,
I'm David Baumgarten.
And I'm Xiya.
and we are KDX Coders. Infographics have come a long way since the first political infographics were published in 1786. The importance of data has always stood at the core of an informed society, and today, coding visual representations of data is one of the central tools of self-informing citizens and the news industry in the United States. Our team, KDX Coders, created our own version of data-driven and interactive political infographic for today's elections. I'll turn this over to David to show us the functionality.
Thanks, Kayla. If you're a campaign manager, you may ask yourself, how should I plan for the next election? Where should we be focused on campaigning? This kind of application could be very useful, lots of utility, functional, great for strategizing. It might even have monetary value in the future. Let's look at how it works. So I'm going to launch a demo of our application inside of Visual Studio. As you can see, we've developed a user interface using WX Widgets UI framework. And in this interface, we have basically a search and a filter at the top here. The search is by the candidate name. So all 16 candidates minus 2 that are uncommitted and no preference for last presidential election. You're able to select a candidate from the search. You're able to select the display source, which is going to essentially return the data set from the given or the selected algorithm and then display it in this table below. Something worth mentioning is that even though you're selecting this display source here, it's actually executing both algorithms and benchmarking the test result or the performance down here in this table in the bottom left, showing how many seconds or milliseconds in this case it's taking to execute each algorithm for the exact same search criteria. So I'm going to go ahead and click search here. We've switched to Carla. You'll see, I don't know if you noticed it the previous time I clicked it, but you saw a loading dialog here flashing that we're loading the data from one of these sources. So I'll do it again quickly so you can see it. You can see that's loading. And at the bottom here, you can see the processing time is updated for both methods. Something worth mentioning also is that this data is in a CSV file inside of our project that's loaded at runtime. So the data is loaded into the project, pivoted, and prepared to be ingested into each of these algorithms. We also have a folder structure full of candidate pictures so that you're able to quickly select a new candidate and click search, and their photo gets updated. With that, Kayla, would you like to share some information on our B tree functionality?
Sure, David. So one of our data structures is the B tree, and the B tree is a self-balancing tree that can store and handle massive amounts of data due to its ability to store multiple keys in a single node. Each key in our B tree represents a single county's election data. And when a user clicks the search button, the program inserts that candidate's election data directly into our B tree function, which creates the tree and returns a vector with that candidate's top 10 counties based on votes. As you saw previously, you can see the time it takes to fully process through the B tree function on the bottom left, and its results are displayed in the table. And with that, I'll turn it over to Xiya.
Thank you, Kayla. The other data structure that we implemented to compare the functionality of the B tree to is a max heap. We implemented an array-based binary max heap, which is conceptually a self-balancing binary tree, just like the B tree, but instead of storing values sorted left to right, it sorts its values top to bottom. Each node in the heap represents a county where we store the county name, state name, number of votes, and the percent of votes for later access. Each node is sorted according to the number of votes, and we reheapify within each call to insert and delete to facilitate easy access of the max node. If you pay attention to the processing time in the bottom left corner, you can see that the max heap is much more performant than the B tree due to its simpler structure and array-based implementation. And I'll hand it over to David to conclude our video.
Thanks. So as you can see, the reusability of this tool is infinite, especially if data were entered into a database that was accessible publicly. The possibilities are truly endless, and users can have access to live, unbiased data. We appreciate your time in viewing this video, and as we continue to improve our coding skills, we look forward to new ways to expand on these kinds of tools. Let us know what you think in the comments section below.